In part A, we need to find the volatility of this loan stock, which is essentially really just a bond, and it has a coupon rate of 8%, and it's going to last for 10 years, and it's redeemable at par. So as always, let's draw a diagram to visualize what is going on. So for 10 years, so let's say this bond has a par value of F. So we're constantly receiving coupons at the end of every year. So this end of every year is going to end at March the 1st. So it doesn't really matter where you start, as long as the interval is a period of 1 year, we can just still use this timeline. So it goes all the way to time 10, and then by the end of it, we will also receive our redemption value. And because this bond is redeemable at par, so we just add F. So first of all, we need to find the volatility, right? So we can find this by considering that the volatility is 1 over 1 plus I times the duration. So let's focus on finding the duration first. So as always, remember that the formula for duration is time times the cash flow times the present value factor divided by the present value of all cash flow. So in this case, we just apply the formula directly. So the first payment starts at time 1, so t is equal to 1. Cash flow is FR, and then the first discount factor is V. And then the payment at time 2, so 2 times FR times V squared. And then there's 3 times FR times V to the power 3, and so on. So it goes all the way to 10 times FR times V to the power of 10. And then plus, so all these payments over here, these are all the coupons. And so we also need to consider the final redemption value. So we have the amount F times the time 10, and then the discount factor V to the power of 10. And then we divide this by the present value of all these payments. So you just get FR times the annuity symbol plus F times V to the power of 10. So let's try to simplify this expression over here. So obviously you can see that this is actually an increasing annuity. It starts from 1, 2, 3, all the way to 10. So immediately we have FR IA 10. And then don't forget this final term over here. This is the redemption value. And then we divide this by the present value of all the payments. So now notice that in this problem, the interest rate, which is 10%, is equal to the coupon rate, which is also 8%. So this is going to help us simplify things, because for this term over here, this is 1 minus v to the power n divided by I. So this I can cancel out with the coupon rate R. So we're going to be left with F times 1 minus v to the power of n plus F times v to the power of 10. So this should be v to the power of 10. So immediately you can see that these two terms, they cancel out, which is always a good thing. And then we can do the exact same thing over here. So we call that for the increasing annuity. The formula is equal to something like this. So the I can cancel out with the R because the interest rate is equal to the coupon rate. So we have F times the annuity due symbol minus, so I shouldn't use N, I should be using 10 over here instead. So the annuity due symbol for 10 years, and then plus F times 10 times V to the power of 10. And then first thing you can see, thankfully the F, they cancel out. And then also there's a 10V to the power of 10, and there's a minus 10V to the power of 10 here, so they also cancel out. So in the end you're left with the annuity due symbol. And then you can actually find this formula in the lecture notes if you remember. So this formula is only applicable if the coupon rate and the interest rate are equal. So if that condition is satisfied, then the duration is just equal to the annuity due symbol. So we just apply this directly, and then so we call that, for part A, we're actually looking for the volatility. So we just take the duration and then we divide this by 1 plus I. So this can be calculated by using this. So just plug everything into your calculators. It should be fairly simple, and you should get 6.71. So this is the answer to part A. So moving on to part B, now we're saying that there is a liability of 100,000 payable at time 7.247. So what does this mean? So when you say you have a liability at that time of 7.247, that means, so let's say within the span of 10 years, at this very time point over here, you have a negative cash flow of 100,000. And now they're asking us to find the volatility and the convexity. So let's do just that. So to find the volatility, this is as 1 over 1 plus I times the duration. And the duration this is simple enough. You take the cash flow, you multiply it by the time point, and then you multiply the discount factor. And then you divide this by the present value of this cash flow, which is equal to the amount of cash flow times the discount factor. So these cancel out. So all you're left with is 7.247 divided by 1 plus I. And then I in our case is equal to 8% as given in the problem. And then once you substitute 8% in, you'll find that this is also equal to 6.71. So it's equal to the volatility from the last problem. And now we also need to find the convexity as well. So always remember the formula, so it's easier to write out first. So you have the cash flow times the time plus 1 times the discount factor to the power of t plus 2, and divided by the present value of everything. And then in this case, it's simple enough. The cash flow is negative 100,000. Time is 7.247. And then we have t plus 1, so 8.247. And then v to the power of 7.247 plus 2. And then we divide this by the present value. So once again, you see that these terms, they cancel out. This you can cancel out with this over here, so you're only left with v squared. So in the end, you're left with 7.247 times 8.247 times v to the power of 2. And then if you substitute everything to your calculator, you'll find that this is equal to 51.2397.